everyone. This is Veena Gandhi, Assistant Professor from Department of BCA Science. I welcome you again in Pointers series in which we will learn subtopic Dynamic Memory Allocation in C. The topics covered in this video are what do you mean by static memory allocation, then dynamic memory allocation, in which functions are supported for DMA like malloc, calloc, realloc and free. Then difference between malloc and calloc, difference between static and dynamic memory allocation, then examples of C program on the dynamic memory allocation and assignment on about topic. In C language, memory allocation is done by two methods, static memory allocation and dynamic memory allocation. Let us see one by one these methods. Now first, static memory allocation. In static memory allocation, fixed amount of memory is allocated during the compile time of the program and stack data structure is used to manage that memory. There are different types of memory architecture available in C language and memory is allocated in two areas, either in stack memory area or the heap memory area. When the memory is allocated at compile time, it is going to store in a stack memory. It is known as then static memory allocation. So all local variables declared in a program are stored in a stack memory at a compile time. Now this memory allocation is fixed. It cannot be changed during the runtime. So it cannot be increased or decreased after allocation. So exact memory requirement must be known in advance. Now deletion of static memory is totally depend on the scope of the variable. As soon as the scope of the variable is over, allocated memory gets free or destroyed. The drawback of static memory allocation is most of the time static memory allocation result in wastage of the memory, which cannot be free when it is no longer needed. For example, suppose array. Suppose if you declare array int a of 100, and if we use only 10 allocation, if we store only 10 numbers in an array, then 90 locations will be what wasted. So 90 into 2, suppose 2 bytes for int, 180 bytes will be wasted. So in static memory allocation, we allocate the memory of fixed amount of memory. It's fixed bytes we allocate at compile time. We cannot increase it or we cannot decrease also it. Now what do you mean by dynamic memory allocation? When the memory is allocated at a runtime according to the requirement and which is stored in a heap memory is known as dynamic memory allocation. So in dynamic memory allocation, size initialization and allocation are done by programmer. So memory is allocated according to programmer's requirement or user's requirement. Now this memory is managed and served with pointers that point to newly allocated memory space in an area which we call heap memory. A heap memory is unorganized and it is treated as a resource. When you require it, you use it, otherwise release it. So all the pointer variables are stored in a heap memory at a runtime of a program. There are 4 library functions defined in stdlib.h file to facilitate dynamic memory allocation in C programming. So in dynamic memory allocation, memory is allocated at a runtime according to user's requirement and it is used and released immediately. So we use pointers for dynamic memory allocation and memory is allocated in a heap memory area. You can see a conceptual memory allocation. First is static memory allocation and second is what? Dynamic memory allocation. In static memory allocation, local variables are declared in a program are stored in a stack. You can say array are stored in a stack here in static memory allocation. In dynamic memory allocation, we declare pointer here int star x. Okay, x is variable stored in a stack, but it is pointing to a heap memory area. So pointer is pointing to what location in a heap memory area. Same thing here, array. We allocate the memory using calloc for array. So array variable stored in a stack, but it is pointing to the first byte of the heap memory area. Dynamic memory management. C language provides four functions for dynamic memory management. First function is a malloc function. Second is calloc function, realloc function, and to destroy the memory, free function is used. The first function, malloc function. It is also known as malloc or malloc or memory allocation method. In C, it is used to dynamically allocate the single large block of memory with specified size. This function returns pointer to a type void, which can be cast into another type. Now, this malloc function does not initialize the memory at a runtime. Means it is initialized with the garbage. Means each block of the memory is initialized with the garbage value. Syntax: pointer variable equal to, and here by default runs void star. Okay, you have to typecast with the given data. Then malloc and byte size here. For example, if we want to allocate the memory for integer variables, so you can say ptr equal to int star. So void star will be replaced by int star malloc. Then we want to allocate the memory for 100 numbers. So 100 into size of int. So 100 into or size of int. Now here size of int may be 4 bytes under 32-bit compiler or 2 bytes maybe on 16-bit compiler. So this statement will allocate the 400 bytes of memory, and the pointer will hold the address of the first byte in the allocated memory. Now malloc function has some drawbacks also. If we attempt to allocate the memory from heap when the memory is insufficient, then it is known as overflow. So programmer has to check in the program for the condition of the memory overflow. If programmer does not check the memory overflow concept, then it may produce invalid result or aborts with the invalid address for the first time pointer is used. Again, malloc function has one or more potential error. If we call malloc function with 0 size, then results are unpredictable. It may return the null pointer. So never call a malloc with a 0 size. Next function, calloc function. Calloc or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory of the specified type. It is similar to malloc function, but it has two different parameters for comparison. Like it initializes each block with the default value 0, whereas in malloc default value is garbage. Now it has two parameters or two arguments as compared to malloc. Now in malloc we only pass the one argument. In calloc we pass here two arguments. So syntax of calloc is the void star pointer equal to void star calloc. And we pass the n comma element size, where n is the number of elements we want to store, and element size, the size of each type of element. It can be a int, it can be a float, it can be char, size of char, size of int, like that. For example, ptr equal to int star calloc 200 comma size of int. So we want to allocate 200 integer numbers and of type int type. So return the pointer to int. So void is replaced by int star here. So pointer will point to the first byte of the 200 bytes. So pointer will point to first newly memory allocated area of the first byte. If the space is not sufficient, then memory allocation fails and it returns null pointer. Next function, realloc function. Realloc or reallocation method is used to dynamically change the memory allocation of previously allocated memory. In other words, you can say if the memory is previously allocated with the help of malloc or calloc is not sufficient, we want to increase the memory more. In that case, realloc can be used to dynamically reallocate the memory. A reallocation of memory maintains the already present value of the previous block and new block will be initialized with the default garbage value. A syntax: ptr equal to realloc ptr comma new size. Now new size contains the bytes of previous block plus new requirement size, and so where ptr is again reallocated with the what new size. Now when given pointer to the previously allocated block of memory, then realloc changes the size of block by extending the previous block or by deleting the previous block. For example, if the memory cannot be extended of the previous block due to other allocation of the other functions, then realloc allocates the completely new block. It finds the completely new block of new size and then copies the previous block to the new block and deletes the old block. You can see in this figure here. You can see here first previous block contains 10 integer by using malloc or calloc and ptr pointing to first byte here 18. Now after using realloc, ptr equal to int star realloc. So we typecast void pointer to int star and then realloc function. Then this ptr is pointing to this previously malloc ptr. Okay, so we want to reallocate that ptr 15 into what size of int. Now first 10 bytes are there previously size, and plus we want 5 bytes more. So give the new size will be what previous block size plus 5 more. So 15 will be size of the new block. You can see here if the memory is available after the end of the block, after 77, if the memory is available, it can extend that block with by assigning the garbage value. But if the memory is not available here, then in that case it will copy the new block of 15 bytes, 15 integers. You can say, okay, 50 integers के लिए it will find the new block and it will copy this existing block, previous block into the new block, and it will delete this old block. Next function is a free function. The free function is used to dynamically deallocate or destroy the memory or release the memory. The memory allocated using the function malloc and calloc is not deallocated on their own. So free function is used to release the memory. It helps to reduce the wastage of memory by freeing it. Syntax: free and then pointer name. Now this pointer refers to the previously allocated block of malloc or calloc. You can see in the figure before releasing and after releasing. Gray shade means memory is released here. The pointer is pointing to 200 integers here. It will point to first byte, first number, and then after releasing this memory, this 200 integers area is released. Let us see C program using dynamic memory allocation functions. Now first we will see how to use malloc function. Now first include the header file stdio.h, then include the file stdlib.h because the malloc function is defined in stdlib.h file. Then include the connew.h for clear screen function. Then in main function declare a pointer ptr, then n and I integer variables, and call the function clear screen. After that ask how many elements you want to store, so caret %d n. Then allocate the memory using malloc, so ptr equal to int star. So malloc is by default returning a pointer to void, but we want to typecast it to integer type, so int star malloc n into size of int. So specify the how many numbers we want to allocate the memory. So we want n elements, so n into size of int. Now check if the memory is allocated or not. So if ptr equal to null, then you can say memory is not allocated. And exit 0 here. Else you can print memory is allocated using the malloc, and for I equal to 0, I less than n, I plus plus, store the values 1, 2, 3, 4 into pointer. Ptr of I equal to I plus 1. After that, we want to print that value. So for I equal to 0, I less than I plus plus, printf percent d ptr of I. And gets it and return 0. Now let us run this program. For element, I want to enter 8. So you can see here, entered elements are 8 and we are copying I value of I. So 1, 2, 3, 4 is copied into pointer. So displays the 8 values. Let's see another program using calloc. So in this program again, include the header file stdio.h, then stdlib.h, then connew.h, declare a pointer to integer, call the clear screen function, enter the elements, how many elements you want to store, scanf %d and %n. After that, so use the calloc function here. So calloc accept two parameters, first number of elements and size of the element. So here ptr equal to int star calloc n comma size of int. In malloc only one argument is given. Here calloc we give two arguments, n and size of int. Then check pointer is null or not. So ptr equal to null, then memory cannot be allocated, otherwise you can allocate the memory. Then for I equal to 0, I less than n I plus plus and ptr of I equal to I plus 1. So we are storing the value 1, 2, 3, 4 like that. And print the elements of the array using for loop. So for I equal to 0, I less than n I plus plus. So printf %d ptr of I. Then after that, free the pointer, free the memory created by calloc. So free ptr, then get ch and return 0. Run this program now. The size of the array is given 10. Then we want to store 10 numbers, so it will display 1, 2, 3, 4 up to 10 by using the calloc. So calloc accepts two parameters and it initializes the memory by default to 0. Now next function, realloc. Now when we want to increase the memory size, which is not sufficient by using malloc or calloc, in that case we can use the word realloc. So we can alter the memory requirement at a runtime by using the realloc. So first declare a file stdio.h, then stdlib.h file, then connew.h for clear screen, and declare a pointer n and I variable. Now here n equal to 5. So now first allocate the memories in calloc. So int star calloc n comma size of int. So first pointer will point to the 5 integers here. Now you check pointer is null or not. If ptr equal to null, then we cannot allocate the memory exit 0. Otherwise you can allocate the memory. Then for I equal to 0, I less than n I plus plus. So ptr of I equal to I plus 1. So we are storing 1, 2, 3, 4 like that. After that, print the pointer array. So ptr of I. For I equal to 0, I less than n I plus plus, printf %d ptr of I. So you are printing the now array. Now we want to increase the size of the array. We want to increase the block of the size. So now n equal to 10. Now for that again, use the function realloc. So realloc ptr comma n into size of int. Now n is 10 years size of int. Now after that we want to print the store the value into array and print that whole array, whole block, new size block. So printf here, for I equal to 5, I less than n, I plus plus. So ptr of I equal to I plus 1. So new value also contain what? 6, 7, 8, like that. So we want to print whole block of size n, of size 10. So for I equal to 0, I less than n, I plus plus. So ptr of I will be display ptr of I. So the alloc has to give the what? New size here. N is a new size here. And ptr is pointing to previously allocated calloc function. So ptr is pointing to previously allocated function. We have to now reallocate the pointer. Run the program. You can see here, first using calloc only 5 numbers are displayed, 1, 2, 3, 4, 5. Now size is increased to 10. So using realloc function, elements are the 1 to 10. It's previous 5 and next 6, 7, 8, 9, 10 are increased. This way we can use the realloc function to change the memory requirement at runtime. Let us see difference between malloc and calloc. The malloc method allocates a single block of requested memory. The calloc method assigns several blocks of requested memory. The argument taken by malloc is 1. Argument taken by calloc is 2. Malloc is little bit faster. Calloc is slower. Malloc indicates the memory allocation. Calloc indicates the contiguous memory allocation. Malloc allocated memory block has garbage value. Calloc allocated memory block has initialized with the 0 value. Difference between static and dynamic memory allocation. A static memory allocation, memory is allocated at compile time. In dynamic memory allocation, memory is allocated at runtime. Now in static memory allocation, memory cannot be altered or changed during the program execution. Now in dynamic memory allocation, memory can be altered during the runtime. In static memory allocation, memory is allocated to assigned to stack. In dynamic memory allocation, memory is assigned to heap. A static memory allocation is best suited if the required size of the memory is known in advance. A dynamic memory allocation is used if the required size of the memory is not known in advance. Example, array. Example here, linked list. Let us see assignment. Short questions. What is dynamic memory allocation? Second question. List the functions used for dynamic memory management. Third, which function is used for releasing the memory? Long questions. Differentiate between static and dynamic memory allocation. Second, explain the malloc and calloc function with example. Third question, explain the realloc function with example. I hope you must understood the dynamic memory management concept. If you like this video, please share and subscribe the college YouTube channel. Thank you for watching.